Okay, section 8.3. Find the slope of the road. Slope, if we're given a rise, like we are here, how the road rises. It rises 240 over a span of 1,500 feet. So if you're looking for the slope and we're given the rise and the run, we'll just use the rise over run method. So the rise is 240 and the run, the span that we're covering, 1,500. We're just going to use that and then reduce. Both of these have a 0 on the end, so we can reduce by 10. 24 over 150, you could reduce by 2. Just keep reducing this until you can't reduce anymore. If you reduce 24 by 2, you get 12. If you reduce 150 by 2, you get 75. Both of these are divisible by 3. So we could reduce a little bit more. 12 reduced by 3 is 4. 75 reduced by 3 is 25. And at that point, we can't reduce any further. And that's as far as we go. Next, find the slope determined by the following pair of points. So in some cases, we have to find the slope given sort of a graph or a road like we just had. Sometimes we're given two ordered pairs. Here we've got 5, 4, and we've also got negative 5, 4. You'll want to remember that anytime we're given an ordered pair, the first one is always x, second is y. And if we're given two different points, we can think of this as the x in the first point, the y in the first point, and then for this one, the x in the second point, and the y in the second point. So we're given a pair of points, and we can use the slope formula. Which is y2 minus y1 over x2 minus x1. And as long as you've got them labeled above, you can just plug those in. Y2 is 4 minus y1, which is also 4. On the bottom, we've got x2, which is negative 5. And then we're subtracting whatever x1 is, which is 5. So on top, we've got 4 minus 4, which is 0. On bottom, negative 5 minus 5 is negative 10. And then 0 over anything just simplifies to 0. Doing the same thing, find the slope determined by the following pair of points. We've got 1, 3, and 2, 2/5. So we've got our x and y, our x and y. We'll call this the first pair. This one the second pair. So going through the same steps, y2 minus y1 over x2 minus x1. Y2 is 2/5. Minus y1, which is 3. And then on bottom, x2, which is 2, minus x1, which is 1. So 2/5 minus 3. I'm just going to go ahead and write that as 2/5 minus 3 over 1. And then on bottom, 2 minus 1 is just 1. One thing about this, it doesn't happen all that often, but we end up with a 1 on the bottom. When you've got a 1 on the bottom of a fraction, you don't need it. So going forward, I'm just going to do the top part. So 2/5 minus 3 over 1. When you end up with fractions and we're subtracting fractions, you do need a common denominator. And in this case, the common denominator, if your denominator is 5 and the other one is 1, you need something that both of those go into. In this case, they both go into 5. So we can make this 2/5. That one doesn't need to be changed because it's already got 5 as the denominator. But for the 3/1 part, if we want to make its denominator 5, we've got to multiply that 1 by 5, which means we've got to take the 3 times 5 also. So if we multiply the 1 by 5 in order to get our new denominator, we got to take the top times 5 also in order to get our new numerator. So 3 times 5 is 15. And we'll just keep going further. Now we've got a common denominator of 5, and then 2 minus the 15 gives us negative 13. Number 4, write the following equation in slope-intercept form. Slope-intercept form is y equals mx plus b. And basically, you just want to get y by itself. And we'll have the x term right after the equals. But mainly, we're just getting y by itself. So in this instance, if we want to get y by itself, we've got to get rid of the 12x, we've got to get rid of the negative 2, and then the y will be all by itself on the left side of the equals. So we'll start off getting rid of the 12x, subtract 12x from both sides. Bring down the negative 2y, and then here you'll notice that the x term is right after the equals. Be careful with this 16 minus 12x. These aren't like terms, so we can't combine them into 4 or anything like that. We just keep them separate, and we're going to put the x term first. Just like up here, the x term is right after the equal sign. And that's a positive 16. And then continuing to get y by itself, we're going to divide by negative 2. And make sure you divide the entire right side by negative 2 also. So the negative 2's cancel, and we get y equals, over here we've got negative 12 divided by negative 2. Negative divided by negative is a positive. 12 divided by 2 is 6 in front of the x. And then we've got the 16 divided by negative 2. Positive divided by negative is negative. 16 divided by 2 is 8. So now we've got y all by itself, and the x term is right after the equal sign. This next one's pretty easy. Number 5, y equals 1/3 x plus 2. Step 1 of 2, determine the slope and the y-intercept. We want to, this is easy, I'll say this, easy if y is by itself. Which in this case it is. Y is all by itself on its side of the equal sign. So y is all by itself. So for the slope, we just have to look at whatever is in front of x. So in this case, the slope is 1/3. And slope is rise over run, so that would mean that the rise is 1 and the run is 3. The y-intercept is just going to be 0 in front of whatever this term is. So the y-intercept in this case is 0, 2. And then graphing the line, we're just going to plot the y-intercept. And then use the slope. So 0, 2, if we go ahead and plot that, 0 on the x-axis, so not going left or right at all. And on the y-axis, we're going up 2. So our 0, 2 is right there. And then we're going to rise, like I said, using the slope. We're going to rise 1. So we're going to go up 1 and then over 3. So starting from that 0, 2, the y-intercept, we're going to go up 1 and then over 3. And that's our next point, and we're just going to combine them. So plot the y-intercept again. Just to recap, plot the y-intercept at 0, 2, and then we're going to rise, which is the 1, and then run, which is the 3. So up 1 over 3. Determine the slope and the y-intercept. So pretty much the same as the last example. Again, this is easy if y is by itself. So what we're going to do is we're going to adjust this so we get y by itself. So I'll zoom in on this just for a second. We're going to get y by itself. So we'll subtract the 6x from both sides. Remember, these are not like terms, so 32 minus 6, we're not doing that. This is 32 minus 6x. Those aren't like terms that we can combine into one term. So they just stay separate, and we put the x term first after the equal sign. Then we're going to divide negative 8. So we get y all by itself, divide negative 8. And then we end up with y by itself equals, so negative 6 over negative 8. Negative over a negative is positive, so 6 over 8x. And we've also got negative 32 over a negative 8, so negative over a negative is positive. 32 over 8 reduces to just 4, 32 divided by 8. And we can also reduce this 6 over 8, which we would want to do. They can reduce by 2. So we end up with y equals 3/4. 6 reduced by 2 is 3. 8 reduced by 2 is 4. Okay, and then hopefully once you get y all by itself, it's pretty easy to spot the slope. Slope is just whatever's in front of x. And then the y-intercept is this, but with a 0 in front of it. So we've got the slope, which is 3/4, and then the y-intercept in this case is 0, 4. And then if we're graphing it, we're going to start with the point. Zero, 4, so 1, 2, 3, 4. And then from there, we're going to rise 3 and run 4. So we're going to go up 3 over 4. And again, not starting from the middle for the slope and for the rise and the run. We're starting from that y-intercept. We're going to go up 3 over 4. So up 3 and then over 4. 1, 2, 3, 4. Number 7, find the equation of the line. I'm going to count the rise and run and the y-intercept. So counting the rise and the run, you just want to pick 2 points. It doesn't really matter which points you pick, but this clearly goes through that point and clearly goes through that point. So if we start at one of them, it doesn't matter which one you start at, but let's say we start at this leftmost one. In order to get to the next point, we're going to go down. So start there. We're going to go down 1, 2, 3, 4, 5. So our rise is -5. And then our run is 1. So from here to here, we're going down 1, 2, 3, 4, 5. And then we're running 1, 2, 3, 4. So going down is negative. Going right is positive. 1, 2, 3, 4. So our slope is rise over run. Rise was -5 and the run was 4. So we got to find the rise and run, the slope, and then the y-intercept. Y-intercept is just wherever it crosses the y-axis. So in this case, it crosses at 5. And you might remember from the previous couple examples that the rise and run, the slope, we put that in front of x. So our equation, we can do y equals -5 over 4x, and then plus whatever our y-intercept is, which is 5. Doing the same thing here, count the rise and the run in order to get the slope, and then the y-intercept. Let's do the y-intercept first this time. Pretty easy. Y-intercept is just 1, 2, 3, 4. And then we count from this point maybe until this point. There won't be dots there. You'll just have to say, oh, it crosses this perfectly. It crosses this perfectly. So I'll just count. So from here to here, we go down 1, 2, 3, 4, and then right 2. So -4, 2. Rise, and then run. And then we already knew our y-intercept was 4. By the way, if your rise and your run can be reduced, so -4 over 2 does reduce to -2. You will want to reduce it. So y equals our slope in front of x plus our y-intercept, which is 4. Find the equation of the line, count rise and run. So on this one, you might look closely at this and see that it goes through that point, also goes through that point perfectly. And then you just want to count your rise and your run. Here, our rise, it goes down 2. In some cases, it may go, up. So in a positive way, and then over. In this case, it goes down 2 and then over 1. So rise and run. And we can reduce that a little bit. Like I mentioned earlier, if we've got 1 on the bottom, we don't need it. So -2 is our slope. And our y-intercept, this crosses right in the middle. So it's not up, it's not down. Our y-intercept in this case is 0. So our equation is going to have y equal to the slope in front of x plus the y-intercept, which is 0. In this case, since you've got, you wouldn't say 5 plus 0, we just say 5. So we're just going to go ahead and simplify this. Y equals -2x and leave off the 0 part. Determine the equation of a line. This is the third part of, there will be a step 1 and a step 2, things that we've already discussed. But here's step 3, determine the equation of a line. These ones are actually pretty easy. Vertical lines, they're like this one, perfectly vertical. It's not at a slant or anything like that. It's perfectly vertical. Vertical lines are x only equations. In other words, x equals something. And in this case, if we count, we just go over 2. In this case, x equals, this would be 1, this would be 3, and in this case, x, our graph, is equal to 2. Every single x on this line is 2. So vertical lines are x only equations, meaning there's no y in the equation, it's only x. X is equal to something. This one is a vertical line also. So I'll write that again. Vertical lines are x only equations. So we would say x equals something. And in this case, -1, -2, -3, -4. In this case, x is equal to -5. Determine the equation of a line. Again, pretty easy, but it's not a vertical line, it's a horizontal line, perfectly horizontal, not at a slant. These are only, these last 2 examples are just shortcuts for vertical and horizontal lines. So horizontal lines are y only equations. So y equals something. We just have to count. So in this case, -1, -2, and this is going to be -3. So meaning there's no x, y only. Number 13, y equals 2. Step 1 of 2, identify if the line is horizontal or vertical. So we just got done doing a y only equation. Y only equations are horizontal. Y only equations are horizontal. You know, we just had that one that was at -3 and it was horizontal. So it's sort of it's the opposite of the axis. You know, the x-axis is horizontal, but y equations are horizontal. The y-axis is vertical, but x equations are vertical. So this one is horizontal. And then there's a vocabulary sheet that may have been passed out or attached to the PDF here. 8.3 vocab states that horizontal lines have 0 slope and the vertical lines have undefined slope. So since this one is horizontal slopes, so we've determined it's vertical, or it's horizontal rather, and the slope is 0. So not a whole lot to calculate there, just remembering that y equations are horizontal and then horizontal lines have a 0 slope. That's it. Number 14, find 2 points on the line and then we're going to determine the slope. This one's pretty easy. This is, you'll want to notice there's no y in the equation. And in section 8.2, when you just have one of the variables and not the other, That means y doesn't matter. We can go ahead and put in whatever we want for y right now. Remember, it's x and then y, x and then y. So if we go ahead and put in 0 and 3, something like that, y does not matter, but we do need to solve for x. And in this case, getting x by itself means we're going to subtract 5, and we get x equals -5. So once we've done that, our x's are just going to be -5 and -5. Y doesn't matter, so we just put in 0 and 3, 4 and 7, whatever you want to put in for those y values. And then determine the slope. You'll have to remember that x only equations are vertical. We talked about that a little while ago. And so if it's vertical, that means the slope is undefined. Vertical slopes are undefined. Horizontal slopes are 0. Okay, last one. Find 2 points on the line. And you want to notice there's no x in the equation. So x doesn't matter. So I'm going to go ahead and put on, whatever on the 2 points, x and then y, x and then y. X doesn't matter. I'll go ahead and put 3 and 7. I should say, your graph only goes from -10 to +10. So don't use numbers for x like 100 or 50 or anything like that. Make sure there's single digits. It wouldn't technically be wrong, but it will not fit on the graph, and the software is not going to let you do it. So pick a number between -10 and +10, single digits. And then just like the last one, x doesn't matter, but we do need to solve for y. Hopefully that's not too bad. Gonna subtract 9. We got 3y equals -9. And then divide 3. Y equals -3. So that means both of our y's down here, -3 and -3. And then step 2 of 2, determine the slope. Y only equations are horizontal, and horizontal lines have a slope that's vertical, or slope is 0 rather.